Welcome back everyone. In this video I'm going to show you a wide area network using a Frame Relay cloud. Cisco Packet Tracer does support Frame Relay. I would have loved to show you a setup for say MPLS or ATM, but it doesn't support those to my knowledge at least. If anybody knows that it does, please let me know. First, a little bit of an overview of what's going on here. I have set this whole thing up because it's a fairly long process. It was made for a very long video, but I am going to show you what I've done, and I will program one of the routers from scratch so you'll see how this is set up. First and foremost, we do have three local area networks. I have this LAN, and this LAN. This is LAN 201.110, this one is 203.110, and this one is 202.110. As I usually do, I have made the gateway addresses be number 10. So this is this interface here is 201.110. The other one is 202.110, and this one is 203.110 right here. Now, the Frame Relay provider's network, I've decided to make that be network 200.110, and as you can see, the interfaces, the serial interfaces here have addresses. So this is 200.111, 200.112, and 200.113. So the Frame Relay provider, let's say, has three customers. This is the first customer, second, and third customer. They all get an IP address from their network, and what they have to do is they have to use a Frame Relay map, which the provider will help them with, to allow this these routers to talk back and forth with each other. Let's take a look at this cloud first and foremost, and you can get the cloud from right here. If I click on clouds, I just pick this PT cloud. There is an empty one where you can add your own modules, but I prefer the one that I have here. If I add this here, you can see that it's got a bunch of serial ports attached to it. Now, I don't need this cloud, so I'm going to delete that one. Yes. All right. So if I open up this, you can see that under the physical tab, we have a bunch of serial ports already, some additional ports here, and you can add some more modules if you wanted to. What I have done, I'm going to purposely sort of demolish this router right here. So let me go ahead and delete its link here. And I will take care of the rest of it later. To make the connection to this, I am going to use a normal cable that we use, except I'm going to make the cloud, because this cloud, the Frame Relay, does provide a clocking mechanism. I'm going to make this be the clock end. So I'm going to take serial 3 and map it to serial 0, 0, 0 over here. Okay. Once I have my router, and let me go ahead inside of my router, and I'm going to delete everything in this router, and let me go ahead and exit all this, and I am going to delete everything. So let me go to conf t, and I'm going to do what's called write erase. Okay, I'm sorry. I have to put a do in front of that. And it says you're about to delete everything. I'm going to say go for it, buddy. And this is all at this point, gone. Another way I could have done it, because this is a simulator, I can just open this up and physically turn it off, take this network interface out, put it back in, and then turn it back on. Okay, and that's going to basically wipe this router, and it's coming up at this point. So all the work that I had done has been destroyed. While this is coming up, there's a little bit of explanation that's necessary. Frame Relay is really not used that much anymore. It's being replaced by ATM, primarily by MPLS. But it was a good technology. It's still a good technology. It allowed you to have shared resources. In other words, we have a provider that has Frame Relay, and they can sell bandwidth in these circuits to various customers without them having to have point-to-point connections. or they have to get lease lines from one point to another point, which would be very expensive. Here, you could share the resources. Now, the way it works is we have these so-called data link connection identifiers, and you set them up. So this is what the frame relay provider would tell you. This is not something that you come up with. Now, here, of course, we're coming up with it ourselves, but they will tell you what your DLCI is. And that is to connect, this, for instance, this router to this router, or this router to this router, and this one to this one, etc. What it is you want to connect to, that will tell you what your DLCI is, and you would have to put that in to your system. You would program that in. For this, what I have done, if I go back into my cloud, if I go under configuration, and if I click on serial 1, you can see that I have a couple of DLCIs. Now, I picked the DLCI that I labeled these routers R1, R2, and R3. So I said, well, let's have DLCI 102, which is R1 to R2. So that's what I called it. Does it have to be called 102? No, it could be called 837, but it probably would make a whole lot of sense in this. It would be easier to understand. So router 1 to router 2 is this DLCI. Then from router 2 back to router 1 is DLCI 201. From router 1 to router 3, there is a DLCI 103. And from router 3 to back to router 1 is a DLCI 301. And from 2 to 3, 203, and from 3 to 2 is 302. These DLCIs have a tendency to sometimes confuse students. Don't think too much about them. Think of them as when you go flying. You go to a terminal and you're told that your gate is D7. Now, that's your DLCI, that's your connection. If you go to D7, you will get the proper airplane and it will fly you to the proper destination. At the other destination, you might come out of gate E9. So that would be the DLCI for that end. So these are locally significant, but you don't need to worry too much about them. It's just a local significance where you're told this is your DLCI, this is your gateway to get out of your local area networks. That's really what they are. It's not much more to them. I connected the serial 1 here to network 1, serial 2 to network 2, and serial 3 to network 3 for obvious reasons. It's easy to keep track of. If I click on serial 2, you notice that I have DLCI 201 for R1 and 203 for R3. Let's take a look at this last one, and I'm going to purposely remove these and then add them. So let me go ahead and select each of these and remove them. So I'm on the serial of this cloud. I'm on serial 3 that I have selected. And for serial 3, I'm going to say, well, 301 goes to R1. And I'm going to add that. And then I'm going to say that 302 goes to R2. And I'm going to add that. So that takes care of these DLCIs that I've created. Now, again, the provider will tell you this. Once having done this, I can go back. I can go to the frame relay for the connections, and I can set up my connections here. And you can see that because I removed stuff, this basically got completely messed up. So let me go ahead and remove this too, and we'll start from the beginning. I am in the cloud, and please let me go ahead and add my cable back in here from serial 3 to this and get back into my cloud. So I'm in frame relay. I have my DLCIs created already, so that's great. What I'm going to do is I'm going to look at serial 1, which is this serial 1 right here. And notice it shows there are 2 DLCIs available, R2 and R3, that I've created. And I can see that R2 right here is this router right here. So I'm going to select serial 1, R2, and then from serial 2, which is this one, we go back to R1. So that's a connection. We add that in. Then I have from serial 1, I'm going to go to R3. 3, which is this one, and from serial 3 right here, I'm going to go back to R1. So I'm going to add this one. Lastly, I'm going to come over here to this serial 2. Let me select serial 2 right here. And serial 2 right here can go to R1. So that makes sense. That serial 2 goes to R1. We already have that. I can also say serial 2 goes to R3. So serial 2 to R3, and serial 3, which is this one, can go to R2. So I'm going to add this. Now this is enough because I have 3 paths. I know what you might be thinking. You're saying, well, wait a minute. There's a serial 2 right here that goes to R1, but we don't need to worry about that because we already have R1 going to R2 with another one of these. So we only need the 3 because there are 3 paths. The others, if you will, work by themselves. Let me go ahead and close this and save this. And I'm going to bring up this router, and which I just wiped out. I'm going to say no. I elected to set up DHCP for these networks, and I'm going to do it right here for you too. So I'm going to say enable config T, and I'm going to say hostname R3. So that changes the host name to R3 right here. So let's first go to the port right here, the Ethernet port. So I'm going to say interface gigabit 00, and I'm going to give it the IP address. This is a gateway address. So this is going to be 203.1.1.10, and that's what I decided to do, and no shut. So that brings that up. Now, these computers, if you go inside of them, I have changed the static to be DHCP. As you can see, they have an IP address from previously when this router was running. But let's go ahead and program the router because the DHCP server was completely wiped out. So what I'm going to do, I'm going to type in IP DHCP. If I do a question mark, I have a couple of options. Let's create the pool first. And I'm going to name the pool after the address range. So 203.110. You can call the pool whatever you want. You can call it, Orlando or Los Angeles, or, the pool for finance or accounting, whatever you want, whatever area this is serving. I just made it the address. So first, the network is going to be 203.110, and we have to give it the mask. And also the default router is 203.1.1.10. There are other things you can put in here, such as a domain name, DNS server, etc. But I don't have a DNS server and I don't have a domain name, so I don't need to worry about that. So I'm going to exit this. There's one more thing I'm going to do. I'm going to say IPDHCP excluded address, and I'm going to exclude the gateway address from being given to a host because that is the gateway. All right, so that creates a DHCP. If I were to go to one of these guys and type in ipconfig renew, it should pick up one of those 2 or 3 addresses, and it did. So we have a working local area network. Now, I'm going to go to its interface S000 right here, and I'm going to say no shut to bring it up. And notice it comes right up because the other end is alive and it's a frame relay. We expect our provider to have their end up and running. And this IP address for this one is going to be network. The frame relay provider tells us, hey, this is the IP address is 200.1.1.3, and this is the mask. So that takes care of that. So that's great. Now we have to specifically tell it that this is a frame relay interface. I'm going to say encapsulation frame relay. So that changes the encapsulation mode for the packets that are leaving to frame relay. And then I have to use a frame relay map. So I'm going to say frame relay. You can do a question mark here if you like. And the keyword here is map. If I do another question mark. So what is this IP version 4, which is just IP or IPv6? And over here it says, what is the specific address? Well, this is an IP address, and this is going to, I'm going to have two of them. There's going to be one for this network right here and one for this network right here. So I'm going to say that from here, I want to get to address to this network 201.1.1.0. IP 201.1.1.0. I'm pretty sure. Let me double check my math here for a moment. So yes, that is correct. So this is going to 201.1.1 network, except this DLCI is going this way is 301. So I'm going to say this is going to network to this interface, which is 200, this one right here, 201.1.1.1, DLCI 301, and then you put broadcast after it. And let me just double check my work. This should be correct. So this is 301 going this way. That should be it. And then I'm going to repeat this command, except this is going to 202.1.1.1, which is this one right here, and that's DLCI 302. Okay, so invalid input detected. I missed my 202.1.1.2. Let me just 1.1.1. I apologize. So that should be it. And one other thing that I need to enable routing. I'm going to say EIGRP. I'm using that for this one as opposed to OSPF. Now, EIGRP requires a number that's an autonomous system, and I'm presuming that my provider has told me we're an autonomous system number 1. They will tell you what that autonomous system number is. Now, all of these must be in the same autonomous system if the routing is going to work. Otherwise, we need to use BGP, Border Gateway Protocol, to do the routing. So this is responsible for two networks right here. This is responsible for network 203.1.1.0 and network 200.1.1.0. And we need to say no auto summaries because EIGRP summarizes routes. I won't go too much into what that is, but I'm going to say no auto summaries. You notice that it detected these other things that they started happening. So now if I've done everything correctly, if I open up this computer right here, now first of all, let me make sure that I have an IP address right here. Let's do ipconfig. And yes, we have a 203.1.1.2. Well, we're right here, might as well try it here. If I want to ping a 201.1.1.1, let's see if that works. And you can see that we have complete connectivity going all the way to that end. Let's try it with this one too. So this is 202.1.1, let's say 2, and that should work too, just as well. Let's give it a try. There you go. So this is working. So at this point, what we have set up is a Frame Relay cloud. This is something that your provider would set up, for you and tell you what your data link connection identifiers are, all that stuff. So you can see just 5 or 6 commands that you have to put in. The routing had to be enabled. The routing, what it's doing, the EIGRP is routing between this network and this one. And again, that is assuming that your provider is using EIGRP, and if they are, they would tell you what your autonomous number is for the system, and you would put that in when you're programming your routing protocol. Well, I hope you enjoyed this one, and if you enjoyed these videos, please let your friends, loved ones know, and I'll see you in the next video.